The most dangerous thing on your plate tonight is not what you think it is. It is not the oil, not the salt. It is the fire you gave to something that was once perfectly, quietly alive. There is something profoundly humbling about the act of cooking. Across every civilization, in every corner of this world, human beings have gathered around heat and prepared food with intention, with care, with love, with the belief that warmth transforms the raw into the nourishing. And in many ways, that belief is scientifically correct. Heat does open up certain foods, breaks down rigid plant walls, makes minerals accessible, kills harmful microorganisms. But here is what we have not always paused to ask. What happens when that warmth becomes excessive? What is the cost of going too far? Consider the humble broccoli. It sits in your kitchen, like a small, dark green architecture of extraordinary biological intelligence. Inside its tightly packed florets lives a compound called sulforaphane, a molecule that researchers have spent decades studying for its remarkable ability to activate the body's own antioxidant defense pathways. It does not fight disease from the outside like a drug. It speaks to your DNA from within, switching on genes that protect your cells. But sulforaphane does not survive prolonged heat. Boil broccoli beyond 5 or 6 minutes, and you destroy the enzyme, myrosinase, that produces it. The broccoli remains. The color softens to something resembling olive. It is still edible, still recognizable. But something vital, something irreplaceable, has quietly left the room. So if what you are cooking still looks like food, does that mean it still is food? Or have you been feeding your body the ghost of nutrition? Let us speak about garlic, that ancient pungent bulb that has been a companion to human health for thousands of years. Cultures across Egypt, Greece, India, and China independently discovered what modern biochemistry now confirms. Garlic contains allicin, a sulfur compound of remarkable biological potency. Allicin has demonstrated antimicrobial properties, cardiovascular benefits, and anti-inflammatory effects that are genuinely impressive when studied in controlled conditions. But allicin is not stored in garlic. It is created in garlic. It is produced only when the cell walls are crushed or chopped, triggering a reaction between a precursor molecule called allicin and an enzyme called alliinase. This is already a fragile process. And then comes the heat. When garlic is added directly to high-temperature oil without being allowed to rest after cutting, alliinase is deactivated before allicin has time to fully form. The aroma fills your kitchen, the flavor deepens, caramelizes, grows golden and complex. It smells like nourishment. It feels like health. But the biology tells a quieter, more sobering story. There is a practice, ancient in origin, validated by modern science. Crush your garlic, let it rest for 10 minutes before cooking, and then apply heat gently. Those 10 minutes allow allicin to fully form before the enzyme is destroyed. It is a small act of patience with an outsized biological reward. This is what I mean when I say that cooking is not merely a skill. It is a relationship, a negotiation between fire and life. Oh, and this raises something deeper. How many of us have been cooking with great intention and unknowingly ending the very chemistry we were trying to preserve? Now I want to take you somewhere more serious, into the chemistry of what forms when we not only destroy nutrition through heat, but actually introduce something harmful in its place. There is a compound called acrylamide, and it deserves your full attention. Acrylamide forms when starchy foods, potatoes, bread, cereals, certain root vegetables, are cooked at temperatures above approximately 120 degrees Celsius through dry heat methods. Roasting, frying, baking, toasting. It is the product of a chemical reaction between an amino acid called asparagine and naturally occurring sugars in the food. It is not added by anyone. It is not a contaminant from outside. It is generated by the food itself under prolonged high heat. What is deeply significant about acrylamide is that it has been classified as a probable human carcinogen by multiple international health agencies. The evidence in animal models is compelling. The epidemiological evidence in humans is still accumulating, still debated in its precise magnitude. Science is honest about what it does not yet fully know, but the direction of the concern is clear and consistent. A potato, eaten raw or gently boiled, carries no acrylamide. Sliced thin, immersed in high-temperature oil until it turns deeply golden and crisp. It has transformed into a vehicle for a potentially mutagenic compound. The potato did not change its intention. We changed its chemistry, and we did it gradually, comfortably, repeatedly. Because the result tasted extraordinary, and because no one told us what was forming in the dark space between the oil and the heat. So the question becomes, when food turns this color, this crisp, this golden, are we cooking it, or are we slowly, unknowingly, cooking ourselves? Let us now turn to the oils, the medium through which so much of our cooking happens, and perhaps one of the most misunderstood elements of the kitchen. Certain plant-based oils, cold-pressed flaxseed oil, extra virgin olive oil, certain nut oils, carry within them extraordinary concentrations of polyunsaturated fatty acids and polyphenols. These are compounds linked in the scientific literature to reduced inflammation, improved cardiovascular markers, and neuroprotective effects. They exist in the oil in a state of molecular fragility. They are sensitive to light, to air, and profoundly sensitive to heat. When polyunsaturated oils are heated beyond their smoke point, the temperature at which the oil begins to visibly break down, a cascade of oxidative reactions occurs. Free radicals are released. Aldehydes form, including compounds like 4-hydroxynonenal, which has been studied for its potential to interfere with cellular function and contribute to oxidative stress. The very oil you chose because of its health properties becomes, at high heat, a source of molecular instability. What is important to understand here is that this is not a condemnation of cooking with oils. It is an invitation to understand each oil's nature, to know which oils welcome heat and which do not, which are suited for dressing and which for sautéing, and to approach that choice not with fear, but with knowledge. The science is not trying to take away your ability to nourish yourself. It is trying to refine it. Because here is the uncomfortable truth. The thing you poured to protect your heart may have become, at the wrong temperature, something working quietly against it. And finally, I want to bring us to something that is perhaps the most universal of all kitchen experiences: the boiling of vegetables. We do it without thought. We fill a pot, we apply heat, and we wait until the color changes, until the texture softens, until what was once bright and resistant becomes yielding and quiet. But in that boiling water, something else is happening. The water-soluble vitamins, vitamin C, and the entire family of B vitamins are leaching out of the food and dissolving into the cooking liquid. They are not destroyed in the way acrylamide forms or sulforaphane is lost. They simply migrate. They abandon the vegetable and take residence in the water that you, in all likelihood, pour down the drain. Its studies on prolonged vegetable boiling show losses of vitamin C that can reach 60 to 80% of the original content in certain vegetables. Vitamin B9, folate, critical for cellular division, for neurological development, for the basic machinery of life, suffers similar fates. This is not a small number. This is the majority of a nutrient, quietly departing in the steam that rises from your pot. Steaming changes this equation meaningfully. Roasting at moderate temperatures preserves a different profile. Even returning the cooking water to soups or stews recovers much of what was lost. These are not radical interventions. They are small, thoughtful adjustments, the kind that only become available to you when you understand what is actually happening at the molecular level inside your kitchen. And so what I am offering today is not a list of foods to fear, nor a verdict on any cuisine or tradition. What I am offering is a different kind of awareness, the awareness that food is not merely an ingredient. It is a living system, carrying within it a chemistry that responds to what we do, to how long we apply heat, to the temperature we choose, to the method we select. And that chemistry, if we understand it, if we respect it, can serve us profoundly. We have always known, in the oldest parts of ourselves, that what we eat becomes who we are. Modern science has simply given us the language to understand exactly how that transformation happens, and exactly where, in the fire, we have sometimes been getting it wrong. Because knowledge, like heat, is a force. And the question has always been the same. Are you using just enough? Or have you been, without realizing it, applying far too much?